Okay. Is there anything in particular you guys want to talk about?
Um, I I'm gonna be doing my experiments tonight because I wanted somebody there with me, and my husband's pretty knowledgeable with that stuff, so I'm gonna do my one and two tonight.
Okay.
Um, I was wondering what like cloud seeding is because I get the process of it of why it's done, but then it comes back down. Is that disrupt like the environment? Like, does it leak into the ground? Is the seeding? Because they shoot into the sky and it comes back down to produce rain, but like it comes down and it like leaks in. What are the seeds like comprised of? I guess.
There are many different things that could be used, but honestly, all you need is salt or smoke. So what works really well are fireworks, honestly.
Uh-huh.
So you should be as concerned about them as you are about fireworks.
Hmm. Interesting. Okay. So it just kind of like evaporates. Then it doesn't.
No, it definitely doesn't evaporate. They're particles that are solids. So it could be I mean, they could ground up table salt really fine and throw it up there, or
Mhm.
put some other kind of salt, like Epsom salt, or something like ammonium nitrate. I mean, that wouldn't be terrible if they were trying to do it over a field. Then you'd be fertilizing it as well,
Yeah.
or you could just have some sort of smoke producing something or other.
Okay. So it's not like some sort of chemical. They're just trying to make it rain. You know,
They're just trying to put particles in the air that are super small that the water droplets can
attach to and way down.
attach to and weigh down. Yep. I just need a place to start.
Okay. Because I've like, heard of it, but I hadn't really like dived into it. So when I saw it on the first experiment, I'm like, like what is that? So I figured I'd ask you.
Yeah, without the cloud seeding or without the basically the nucleus, then the water molecules as gases have to run into each other.
Mm-hmm.
And gas particles are ridiculously small. And you might think like a smoke particle is really small, but it's millions of times larger than a gas particle. So it's a lot easier for them to run into those than they are able to run into themselves.
Hmm. Interesting. Okay. Um, I was reading in the last part of chapter two um, about chlorofluorocarbons and
Yep.
that they're in a lot of different things. I didn't know that they were part of the expellant for or the gas that was used for inhalers to like help you get in your lungs basically. It's not the actual medicine part, but the expellant that like gets it into your lungs. I didn't know that that was used, not anymore, but that's really interesting to use that.
They were trying to use something that wasn't going to react with the medicine,
Mm-hmm.
and that expanded very well and was very volatile. Volatile meaning turns into a gas very easily.
Mm-hmm.
So yeah, that's what they went with before they realized it was a really bad idea for reasons they hadn't thought about or even known about.
Mm-hmm. So it was banned. The use of those were banned. Um,
In the
in
70s.
the, yeah, but in the United States, I mean, is it used in other countries, or it was just the United States? It's like we're done with that.
For the most part, the issue with those is most countries weren't making them. So if you wanted them, then you purchased them from the United States and then did whatever you wanted with them in your country. So when the United States stopped mass producing them, so when like a chemical company was like, all right, refrigerator companies, GE is no longer going to buy this product because they're not allowed to. So let's just stop making it. So when the suppliers disappeared, the rest of the world stopped using them because it simply wasn't available.
Mm-hmm.
But some companies had some countries and some companies still do produce these in certain amounts because they're useful for purposes that are more secure, I guess you could say. Less likely for them to be
Damaging.
to find their way to the environment.
Hmm.
But 2 years ago, there's a professor at University of Boulder, UC Boulder, University of Colorado. Well, I think he's a professor at a college or university in Colorado, and he's sort of like the de facto. He's constantly checking the atmosphere person. Like every country does it, but and some countries do it for really, really specific reasons. Like the countries that border along Russia, they are always monitoring for the winds that come from Russia to make sure there isn't anything in them, like, oh, I don't know, Chernobyl radiation. But for the most part, they're just checking for weather stuff. But this guy's actually checking to see if anybody's doing anything nefarious, and he found a large amount of these chlorofluorocarbons 2 years ago being produced in China. So he just set some stations off the coast and outside of the Chinese border, and then when those gases came across, he ended up pinpointing to a province in western China. And after that information came out, the Chinese government supposedly didn't know anything about this. And as soon as they found out about it, they supposedly stopped it from happening. And this guy kind of confirms that he's not detecting those chlorofluorocarbons anymore. But who knows how long that this company was doing that.
Hmm. Probably for a long time, and that the guy in Colorado just kind of stumbled upon it, and China's like, "Oh, we never knew about it."
I honestly believe that the country of China wasn't aware of what was going on, and that this company, specifically this person running this company, was making styrofoam as cheaply as possible, and that was his way to make it as cheaply as possible.
Hmm.
I don't know if you remember an incident that happened about 8 years ago with toys that were coming from China, that
The wood toys, they were covered in that
paint that had
the
lead and other like
yeah.
chromium 6 and stuff in it.
Hmm.
So
Yeah.
those there were four companies that were involved in that scandal, and all four of the people who were in charge of those companies mysteriously died within 3 months of the publication of that information. The Chinese
Hmm.
government doesn't want bad publicity, so they died in like suicide, car accidents. It was just a little too coincidental that they all died like that. So
Yeah.
my guess is you made us look bad, so we're just gonna get rid of you. That's
Yeah.
kind of what it felt like.
Pretty much happened over. So I know that there's like the cheaply made makeups and stuff for like kids that are coming overseas. They've been tested and have lead in them too. There's just so many makers. It's hard to keep track and to track these people down and shut them down. So like when you go to you know, even like the knockoffs of major makeup brands, if you buy them on eBay and stuff. I remember listening, or I was watching something. I think it was on Netflix. It might have been a lady bought this foundation, or no, it was like a lip enhancer or something from a major brand, and she bought it from eBay because it was really really cheap, and it was, the name brands are really expensive. She's like, oh, it's a great deal. And she put it on, and I guess they used super glue in the lipstick, and her like lips shut together,
Wow.
and she had to go to like the emergency room, and it was like a whole big deal. But it's like you have to be careful where you get your stuff from. It's not counterfeits. They're using all types of additives to try and make it look like the real thing. So,
That's terrifying.
like my husband says, it's really expensive tools. Buy once, cry once, but it's quality stuff. You're not going to get cheaply made products.
That's pretty much Snap-on's tagline, right? Buy it from us, and you won't ever have to buy another 9/16 box end wrench again.
He's like, now you're gonna get him going.
Regardless, if you find a rep, you can get that. If it broke, you can get the tool swapped out. Like the same kind of thing with Sears and Craftsman years ago, but they don't honor that anymore.
Yeah, I missed that. Ugh. But yes, like another question. I'm sure it comes to me. If anybody else wants to ask questions, until I find my question.
Bethany, Joe, Alejandro, anybody? The exam's Friday. I'm not sure. Some of you have done both the chapters and already turned those things in. Nothing?
The exam is due like Friday by midnight or something, right?
Yep.
And then both labs and both reading guides are due tomorrow.
And that one will be a quarter of the way through. Thursday. Yeah, tomorrow.
Last Thursday, yeah. And then our paper is due March 9th, right?
Sounds right.
Okay. I like wrote everything down just so I remember.
If you look at the quiz, or sorry, the calendar, let me go to March 9th. Yep, paper's due March 9th.
I made myself a cheat sheet guide so I can just at a glance see everything instead of having to log in and stuff. For me, just having a visual is it's a lot better than having to go onto the computer. I can just be like, when is that due again? Okay, perfect. I have this much time to do it.
I wish we could make the phone app work, but right now it doesn't work for us because you have to go through the MyCGCC portal. But we're switching over systems, so there's a possibility that we might be able to do something so the app works.
Oh, it's like a Moodle app, right?
Yeah, it works really well for instructors because we log in a normal way, and so like I'll get notifications when stuff's due, and I can tell it how soon I want the notifications are for stuff.
Okay. I guess that would be convenient. I mean, I can just log. I don't think I've ever logged in on the MyCGCC on my phone.
It works.
I always freak out that my phone's gonna like die and I'm gonna lose information, so I don't.
Gotcha.
And I'm just paranoid like that, but yeah. I don't know if anybody else has questions or if you want to talk. I can't find my question that I had, but I think it'll come to me.
So did you guys, were you good with the stuff from like 2.4 about light and wavelengths and whatnot?
Because we talked about that last time, right?
No, we didn't talk about radiation in any way. We didn't talk about electromagnetic spectrum frequencies or wavelengths or energies or anything.
Maybe I had that was one of my questions, or I was going to ask about that, but you went into something else. It's funny because like when I was doing this chapter, my questions, I was going over, 2.4 and doing like the nanometers and the like this whole section on like scientific notation, and I was learning that in my algebra class the same day. I didn't know.
That's funny.
I thought that was funny. I was like, oh, that's kind of cool. This makes sense now. So with the wavelengths, UV, so the rainbow is the visible part of it. You can't of course can't see UV or the infrared, but the visible portion of it is just it's like a rainbow, right?
Yeah. So do you see this image that I have up here? No. Wait. How about now?
No.
No?
Yes, now I can. Okay.
Okay. So this is just like, let me read Bethany's comment. Okay, good. So this is referred to as either the electromagnetic spectrum or electromagnetic radiation, and it's a super fancy term for the word light.
Mm-hmm.
So you definitely know these names. So the visible spectrum, obviously we know the colors of the rainbow. Then
Mm-hmm.
IR stands for infrared, and we usually think about that being like just heat. So if you turn your stove top on and you put your hand near it, but don't touch it, it feels hot. So what is that? That's energy, and the energy is in the IR spectrum. And the IR spectrum, if we look at the way this works, is this M down here. This is meters, and this upside down Y, cursive looking Y, that's the symbol for wavelength. So this is how long the waves are. And so this is 10, like this one right here would be a 1 meter long wave. So the waves, so light sort of behaves like waves in the ocean.
Mm-hmm.
And so if you're watching waves, the peaks of the waves, whatever their distance is away from each other, that's your wavelength.
So
So,
lower the frequency, basically.
and the frequency is the inverse of that.
Uh-huh.
So it's the number of times a wave passes your point, that's your frequency. Or you can look at it the other direction and say, how long are these waves? How big are they? So it's two ways to talk about the same thing. With light, it's super easy because we know that the light travels at the speed of light. So I don't have to worry about the water, if I'm talking about the ocean, moving at a different speed because light's always moving, well, basically always moving at the same speed. So if we go here to the far right, these are radio waves, and these are really long radio waves, like really long, like up to nearly 1 billion meters long, meaning the wave goes up and then it takes 1 billion meters for it to come back up again. They can be that long. And on the other side of that, where we've got X-rays, past X-rays is cosmic rays, and those things can be as small as like 10 to the negative 18th. So that means if you had a meter stick, which is a little longer than a yardstick, you could have, let's see, that would be billions, trillions, quadrillions, pentillion. So a 1 with 18 zeros after it, that number of waves could fit on that meter stick. So they can be super, super ridiculously tiny, close to each other, or they can be really, really long. The light that we're used to seeing, or the light that we can see, is the visible spectrum, and those are in the wavelength range of about 380 to 750 nanometers. So that's billionth of a meter. So that means you could get 750 red waves on a single meter stick, or you can get, no, is that backwards? They're 750 nanometers long, and so the 750, the red is the longest of the spectrum, and the other side, the violet, is the shortest of the spectrum. You can see that the violet is about half the size, less than half the size of a red. So this lends a couple of things to explaining this electromagnetic spectrum. First off, that the amount of space of all the total light that we can see is just a sliver. Like there's a lot of radio waves, long waves. There's a lot of AM and FM and other stuff stuck in there. Then there's microwaves, and then there's infrared. We can't see any of that stuff. And then there's a sliver of visible light, and then there's UV, X-rays, and then gamma rays to the left of that. And so those are another huge section of the spectrum that we can't see. So we can only see a tiny little sliver of all the possible rays of light, which might sound like, oh, sad, I can't see all the rest of this stuff, but it's actually really, really good. Because if you turned your stovetop on, turn it on high, it would be like a spotlight shining at your face if you could actually see it. There'd be too much stuff going on, meaning like, so right now you are being pummeled by AM, FM radio. You're also being pummeled by the radio waves that are within that AM, FM range that deal with cell phones. So what if you could see all that stuff?
We'd probably go blind.
It would be like you were standing in front of some car headlights all the time. We wouldn't be able to see anything because everything would be super bright to us. So even at night, you'd still have all the radio waves and whatnot, and so all that stuff would still, light up stuff. Um, so what else do I want to talk about with this?
So is that like with the long radio waves? Is that like ham radio?
Sure.
That's
Yeah.
how you can get, to talk to somebody states away or
Sure.
farther
Absolutely.
than that?
The longer, so the interesting thing about the wavelengths is the longer the wavelength is, the less likely is it going to interact with something. So if you have a really long radio wave, so the really long radio wave, the one way you can think about them is they're allowed to be used only in, some of these wavelengths are allowed to only be used in avalanche beacons. So you're hiking around on a mountain and you get caught in an avalanche. You don't want the radio that you have that's transmitting your location. You don't want those radio waves to be blocked by the snow on top of you. So the radiation that they choose basically goes through anything except for an antenna that's perfectly tuned to receive it. Does that make sense?
Yeah.
So the same thing with submarines. If I'm in a submarine and I want to talk to, I don't know, someplace else, I would use a really long radio wave. That way it will get through the water and then get out. Um,
So it's shorter rays like X-rays, it's going to penetrate something closer.
and then they'll interact with stuff. They can penetrate for sure, but all of these things penetrate. And then when it's penetrating, it'll interact with something, and that'll be a bad thing. So the UV and the X-ray and the gamma rays, those things are going to interact with things inside of you and interact with other objects and do bad things. And then the stuff on the other side, they go through stuff and they don't interact with them in a way that's bad.
What about microwave though? I mean,
No.
if you're standing too close to the microwave,
What happens?
get a headache maybe.
No, that can't happen.
What?
That cannot happen.
You can't get a headache from standing in front of the microwave.
No, that's not possible.
Old wise tale then, I guess.
So all a microwave does is it happens to be tuned to the resonant frequency of water molecules. So a water molecule looks... Can you see me drawing this?
Yes.
So a water molecule is this bent structure, and it's not fixed in its distances for the hydrogen and the oxygen. The hydrogen will move in, the oxygen will move in, and then they'll move back out. So it's sort of like a slinky. So this keeps going back and forth, and this goes back and forth. And the cool thing about the microwave is the microwave radiation comes in and makes this bond move back and forth faster and faster and faster. How do you know that? Because when I put a piece of pizza in the microwave and I turn it on, it gets hot. So why did it get hot? Because there's water in pizza. Does that mean it won't heat anything that's not made out of water? No, because it'll interact with other bonds and other substances. You can put a plate in there, and sometimes you put a plate in there and it's got food on it, and then you can't touch the plate, right?
Yeah.
Like that plate is just, that plate's going to be too hot, so you come with a hot mitt. And then other times you can put a different plate in there, and it could be in there for 5 minutes with potatoes on it, and you can pull it out with your hand because that plate didn't get hot. So that plate doesn't have a bond inside of it that resonates with microwave radiation. So the reason it's really good for the kitchen is we tend to eat things that have food in it, water in it. And so anything that's got water in it will heat up because the water molecules themselves will be forced to shake and move around faster. And that's all temperature is, making the molecules move faster. So the only thing you can do with the microwave is make water molecules move faster. That's it. They might be moving so fast that bad things happen and the food gets too hot, but the only thing that's going to happen is it gets hot.
Hmm.
So we need to make a really definitive distinction here. So can you see the spectrum again?
Yeah.
All right, so do you see my cursor?
Yes.
Okay, so I'm drawing a line in between violet and ultraviolet. So that's the differentiation between visible light, so violet's here, and then ultraviolet here. So ultra is just telling you that it's shorter wavelength. So these shorter wavelengths have more energy in them. So as soon as I get past violet, I'm into ultraviolet. And then this radiation and anything past violet has the ability to break a chemical bond. All
Hmm.
right. So if you can't break a chemical bond, then you can't, then certain things can't happen to you. So what is it? What's the, I don't know if you want to call it an old wives' tale, or what's the, what do people say sometimes about cell phone radiation?
It can give you cancer.
Yeah, and that's a complete and utter impossibility. It is simply not possible. So cell phones are down here in between in this radio wave area where the FM and AM radios are. And
Hmm.
everything on this side, on the right side of UV, doesn't have enough energy to break a bond. And the term for that is called ionizing radiation and non-ionizing radiation. So
Hmm.
UV, X-ray, and gamma rays all are ionizing radiation, meaning they'll go into your body and they'll break a bond, make two ions, and then who knows what's going to happen inside there. The stuff violet and then blue, green, yellow, orange, red, infrared, microwave, and all the different types of radio waves, they do not have enough energy to actually break a chemical bond. Period. They can't do it.
Hmm.
So if they can't break a chemical bond, then they can't break a DNA molecule. And if the DNA molecule can't be broken, then you can't cause cancer. So anybody who's talking about, oh, cell phones cause cancer, there's two problems with that. One, why haven't the cancer rates skyrocketed in the last 10 years? Because everybody's using smartphones. And another reason is we know, scientists know it for a fact that that radiation is not powerful enough uh, to cause a bond to break. All right, so now you don't have to believe me on that, but let's think about this for a second. So let's say that we're the radio wave or the cell phone radiation that we're talking about is somewhere right around in here. Okay,
Hmm.
and so that wavelength is about, let's say, 10, no, yeah, 10 meters. Okay. As you get smaller, the waves get smaller, they have more energy in them. So here we are with my radio or my cell phone radiation, and here we are all the way over here with red light. So if somebody shines a flashlight on you, and a flashlight has red light in it because it's the whole spectrum, are you going to freak out like you're going to give me cancer?
Yeah.
No, I mean, that's completely silly. Why? Well, look at the radiation amount here. This is 10 to the negative sixth. So the difference between 10 to the negative sixth and, and 10 is 10 million. So cell phone radiation has 10 million times less energy than white light. So are you scared of white light?
Yeah.
No. It's not like you're walking around your house turning your lights off because you're worried that they're going to give you cancer, because it can't. And cell phone radiation is 10 million times less powerful than visible light. So it's utterly impossible.
I have a question.
Sure.
I had heard a while back of a so I guess this is a woman thing, but when I was in high school, so like 15 years ago, um, a lot of women would put their cell phones in their bra. I don't
Yeah,
know why they did that, but
because
they
it's
put it in their
convenient.
bra because it's convenient. Yeah, who said pocket? You know? But I had heard that
It's wrong.
some women that were doing that was affecting their lymph nodes
No,
because the phone was always constantly there.
no,
No.
it's not possible. The only thing the phone could be doing is being like a warming pad.
Mm-hmm.
It's not. It's physically impossible. You're asking. You're asking like a 2-year-old to pick up a dump truck.
Hmm.
It is there is no way that it can actually do it.
Okay, well, that's good to know then.
The third way that we know is in Finland, Switzerland, Sweden. I think it's Sweden. When you're born in Sweden, you get something that's like our social security number. And anytime you do anything, um, like you want to buy a car, you want to buy a cell phone, you want to go to the doctor, anything that you want to do, like that you would pay for with a credit card, they have this number on you. So as soon as cell phones became a thing, everybody who bought a cell phone had this number attached to them. Well, over there, all of these records are interconnected, meaning you bought a cell phone and that cell phone information is now connected to all the rest of your information that the government is holding on to, like your health records. So it was a really easy meta study, meaning they just took all of these numbers of these people who had cell phones and put them against people who didn't have cell phones and then check their medical records. There's no difference between the cancer rates between the people with and the people without the cell phones. And that was a long time. It's like the initiation of cell phones. That's how long that you were able to track the results of those people having cell phones versus the people who didn't have cell phones.
Was this a study that people were aware
There
of?
was no there was no study. It had there was no like actual study where people were keeping track of stuff. They literally looked at the data after it was finished, right? So they knew every single person who had bought a cell phone and when they bought a cell phone, and they also knew they knew all of those people's medical records. And so they also knew everybody who didn't buy a cell phone. So if cell phones cause cancer, then since they knew everybody who bought a cell phone and when they bought it, they just, do those people have more cancer than the people of the same age who didn't buy the cell phones? And the answer is no.
Hmm.
So there isn't if somebody says, oh, there's a study out there that shows cell phones cause cancer, you should say, show me the study, because one doesn't exist.
Mhm. Well, that's good then.
And again, we can walk back to this energy thing. The the radiation that's here is your cell phone radiation. Are you scared of standing in front of the stove top and turning the stove on? Are you worried? Has anybody ever said the stove is going to give you cancer?
No.
No. Boiling water on top of your stove isn't going to give you cancer. And look at the difference between these wavelengths, which are say right in the middle, 10 to the negative fifth, to this one, which is 10 to the first. That's 6 orders of magnitude. That's a million. So this has a million times more energy than this does. And you're not worried about this. So you shouldn't be worried about this. I mean, right now you're getting pummeled with tons and tons of radiation. I mean, I'm looking in your house. Where is it? Where's the Zoom thing? Why is that not? Stop sharing that. Okay, so you have at least 3 lights on in your house, and those lights have 10 million times more energy than cell phone radiation. You're not worried about them. You shouldn't be worried about the cell phone. So,
In regards to infrared, I'm trying to come up with a question that's in my head. Is too much infrared bad?
infrared is just latent heat that comes off of stuff.
Okay, so like some of it would be good for you then.
Are you cold?
No.
Okay,
I'm
then
just wondering.
you don't need more.
I've seen of like infrared saunas. That's what I'm thinking.
Oh,
like what's
an infrared
the difference
sauna
between
is an infrared sauna is literally somebody who's taken a stove burner or something just like a stovetop burner and put it into a wood building. That's it.
that?
Like radiant heaters that are on the ground, like floorboard heaters, those are infrared heaters. So all they did is they took one of those and put it inside of a cedar wood building and gave it a fancy name. Nothing else to it.
just a regular sauna is just water over stones sort of a thing, but the infrared is using that process.
They're the same thing. There isn't anything different about them. So the only difference is one of them is really visible and the other one's not.
I see.
Like
Okay.
infrared is heat. So if you're in a space and it's warm, there's infrared there. I'm assuming it's
Mhm.
not, I mean, I know it's sub 40 outside at my house. It's probably sub 40 at your house. It's probably not sub 40 degrees inside your house. So your house is full of excess ultraviolet radiation or
Mhm.
infrared radiation. And you're happy about that because you're warm.
Mhm.
So no, infrared can't do anything to you other than make you hot. I mean, you could get so much of it that it burns skin, but that's not the same thing.
Mhm. Okay. I guess it just helps with circulation. That's
It
kind of what I'm thinking.
it can for sure. I mean
Mhm.
that and an irritant like Tiger Balm or something like that.
Yeah. Yeah. Because I worked for a doctor when I lived in California that had a like an infrared sauna set up in the back for patients. I hadn't done it because just never had time to do it, but I'm like, what is it? And of course, I didn't even ask her like, what's the difference between that and that? I probably would have found out sooner, but um,
If you got a space heater and set in front of it, that's the same thing. There's no difference. The infrared sauna is a room that has a space heater in it, but the room is usually made out of cedar or some other wood.
hers was like a zip bag almost. You were like in a bag that um, really know how to describe it. You wasn't like a wooden. It wasn't like a wood box or room like a normal sauna is like at a gym or something. This was like literally like a chair inside of a bag that you zipped up and you could only see your head.
That's pretty funny. So
Yeah.
you just got into a big plastic bag and they put a heater inside of it. Yeah.
Yeah.
Okay. Somebody probably sold that for a lot of money, and really, it's just a plastic electric blanket. You want an infrared heater? Buy an electric blanket. That's an infrared heater.
Mhm.
Bethany just said something. Do the infrared messengers have UV rays in them? No, they have infrared rays in them. So, like a remote control for like an Apple TV, or the remote control that's on an Xbox controller, or well, actually, not an Xbox controller, not anymore. Um, like a regular television remote that you actually have to point at the TV. You push the button and you can't see any light come out, but light is coming out because it's infrared light. And so there's a sensor on the TV that can read infrared light, and it sent a signal with UV, and it changes the channel or turns the volume up or something like that. So it literally is just a little bit of infrared light. You wouldn't want a remote control that was UV because it could possibly cause cancer.
What about uh like like laser pointers, like the really strong laser pointers?
So
What
you
are
can
those?
see it, right?
Yeah.
So it's visible light,
Uh-huh. Oh.
right? It can't be UV or IR or microwave and any of the rest of the stuff because you can see it.
Hmm. There's somewhere so it's just a really strong red flashlight, pretty much, but like more
That's
concentrated.
exactly what it is. Like those lights that they use to look for airplanes in the sky, the big like
Yeah.
searchlight things. Have you
Yeah.
ever been near one?
They're really, really warm.
Really warm is an understatement, like really big understatement. In one of the Batman movies, he threw a guy on top of one of them, and as soon as I saw that, and he put him on top of the spotlight thing, and then it made it look like the Batman symbol in the sky. And when I saw what he did, I just started laughing because
You're
that
like,
guy's
this is Batman.
clothing
This
would
is
be
fine.
his clothing would be on fire. His blood would be boiling because there's so much light there. It's still energy, and so you'd
Yeah.
still be absorbing it. It doesn't matter that it's white light or UV light or gamma rays. It's still energy. And I mean, you're not going to turn your stovetop on and touch it. There's too
Yeah.
much heat there, and heat again, it's just light. So you could do the same thing on a smaller scale with a laser pointer. And so the
Mhm.
laser pointer could be very powerful, powerful enough to cut through something. Like they sell little laser pointers for people who do craft stuff. They want to like write something on a piece of blockwood and it lasers into it. And yeah, it's just
Mhm.
a really, really powerful, bright, say blue or red flashlight.
Like I know there's like really strong ones where um, the FFA is like can't point them at planes because the light is so strong you can actually reach to the cockpit and stuff.
Yeah, people have been arrested for stuff like that. People have been arrested for stuff like that at football games where they're trying to take the laser pointing and distract the quarterback as he's trying to throw the ball and you shoot that into his
Uh,
eyeball and he can't see.
I
Yeah.
haven't heard of that. I don't watch sports, so probably why I haven't heard of it before. But I guess that makes sense then. It's fun with cats though, as long as you don't point in their face.
Yeah. Cats enjoy it for sure.
Actually, dogs too. Yeah. Um, um, the polar stratospheric clouds. So those may happen in Arctic Arctic conditions, like the solar or the southern hemisphere.
Yeah, the South Pole and North Pole.
Uh-huh. So you can only get those in those areas. You can only get those sort of clouds in those areas.
Yep. It's partially it's due to just I mean that's just what they call them when they're there because that's where the Arctic and the Antarctic are. But the clouds are a little bit different than the clouds up here because of the Coriolis effect. And do you remember that from like general science in middle school, high school? Like when you flush the toilet, it spins, right?
Yeah.
Okay, so imagine you have a bucket of water and it's on a merry-go-round, a small merry-go-round, and you put the bucket of water there and then you spin the merry-go-round. What happens to the water in the bucket?
It swirls around.
It swirls around. So you've got water stationary in a toilet, and then you allow the water to move. And what's the earth doing underneath the toilet, underneath the water? It's spinning, right? The earth is a globe that spins quite fast, relatively speaking, which is, part of the flat earthers. Like, how can we be spinning this fast and we don't feel it? Well, how can you be driving 75 miles in a car and not feel it? Because you're moving 75 miles an hour. So we're moving the same speed that the planet is. So the water is sitting there, and then when you allow it to move, the earth moves underneath it. So the water spins in the same way that it would spin on a merry-go-round. So that water does that because it's a fluid. Well, air is a gas and it's a fluid. So the Arctic and the Antarctic are sort of like the sewer system for the planet's atmosphere. So you put something up into the atmosphere and then the earth is spinning underneath it. So you get the Coriolis effect. And in the same way that the water spins and goes down the drain out your toilet, the air spins and goes to the North Pole, or it spins and goes to the South Pole, depending on what side of the equator you're on. So the hole in the ozone layer is at the poles because that's where the chlorofluorocarbons, the things we were talking about immediately, that's where they end up concentrating, which is super convenient for humans because people don't live there. I mean, it would be if the hole was over the top of New York City, that'd be pretty bad because then everybody in New York City couldn't go outside without an umbrella.
So it's kind of like the end of a slide at the very bottom of the slide. Everything
Yep,
kind of just.
yep, absolutely. Or like around a waterfall, at the bottom of the waterfall, there's like a ridiculous amount of trash, right?
What?
Trash, like if you've got any debris. So by trash, I mean it could be anything. It could be leaves,
Oh,
branches, and
yeah.
whatnot. Everything ends up in that pool down there. it gets really foamy down there. Why? Because all of the things that are in the water end up in the same spot, and so those surfactants and anti-surfactants end up conglomerating in the same spot, and so you get foam. All the different places, like we were at the coast at the beginning of the year, and I'm sure you've been there and seen huge mounds of off-white, dirty-looking foam, and it gets stuck there. Just all ended up in the same spot. So the poles are the place where the atmosphere's sewage goes.
Interesting. Definitely gives a visual for what I'm reading.
Good. What else we got?
For the labs, so when you say record all observations, like what do you mean as far as that?
When you're doing each step, if something changed, if there was something that happened, then you should write down what it was that happened that you saw.
Okay. But not like just the process of like what I'm doing, but like what each reaction was during that process.
Yeah, well, you did something, and then was there anything observed when you did that thing?
Okay, I see. And then the questions of after each of the labs. Okay. So far, with just the 2 labs, I had everything in my at-home kit. Thank goodness. So far.
Good.
Pure as rain. So I know what you meant by that. It's like what's wrong with the phrase pure as rain. Would there be a place that would be like pure rain? Like would be less amount of rain? I mean,
You bet. The further away you are away from some place, then the more pure your rain is going to be. So if you live in Pennsylvania, your rain's bad. Any idea why?
because the way that the air is moving or the everything's blowing that direction.
Okay, but there's got to be one other problem, one other issue.
I'm not sure.
Just a sec. Just trying to pull something up here. Do you see this map?
Not yet, but oh, yep, there it is. Okay.
All right, so you live here in Western Pennsylvania. This is all of this stuff here. This is where manufacturing occurs. Ohio, Indiana, Michigan, Illinois, and southern Wisconsin. There is a ridiculous amount of stuff getting built here. So you have a lot of factories, and these factories are pumping things into the atmosphere, goes up into the atmosphere, it comes over here, and then it rains down on Western Pennsylvania.
Okay.
So what if you lived in, I don't know, Hawaii? What's west of Hawaii?
Japan.
After a very, very, very long time, or long distance, you get to another country, right?
Yeah.
So what I'm saying is by the time the air has gotten to Hawaii, all of the particulate has been rained out into the ocean. So what kind of air gets to Hawaii? Pretty clean air.
Pretty clean
I
air.
haven't been there, but here's beautiful.
So the West Coast is pretty clean air for the most part, unless you live in like Los Angeles or something.
Yeah, and the reason Los Angeles is bad is because it's got a backdrop of mountains that stop the air that's in Los Angeles County from leaving Los Angeles County. So if you're just off the coast of Los Angeles and say Catalina Island, the air is terrific. I mean, you've been to the Oregon coast. Does the air smell bad?
I
No.
haven't been to the Oregon coast.
What? Seriously?
I'm not an Oregon native.
Okay. Uh, well, don't go unless it's summer because it's freaking cold.
I've actually been to the Washington coast. I've done
Oh,
like all
okay.
around, but I haven't done the Oregon coast for some
Okay,
reason.
fine. Washington coast. The air there is clean.
Yeah, it feels clean
It
there.
feels clean because there isn't anything for thousands and thousands of miles. There's no pollution being generated into the atmosphere for several thousand miles. So all of the stuff that was produced in Japan and Eastern Russia, by the time it gets to Washington, has been rained down into the ocean. So you don't have to worry about it.
Hmm.
Does that make sense?
Yes.
So yes, some rain is much cleaner than other rain, but it's all dirty. Like here, Oregon, Washington, we're pretty clean, but you've still got like stains on your car after it rains, right?
Yeah, especially when you have a black car, you can definitely see all the spots.
Right.
Because I mean, even though you have like a clean state, there's not like a lot of debris and I don't know. Never mind. You can't really have like a clean rain state because it just everything blows from out of state.
Right. Your best option is to be on the west coast of something.
Yeah. Hmm. Just not California.
Well, as long as you're,
On the
it's
coast.
nice. It's nice in, say, Redwood City or Big Sur or even San Diego. It's there isn't a backdrop of mountains and a ridiculous number of people all concentrated.
Yeah.
If the people all left Los Angeles, it would be really nice there.
If they left anything for us. I can say that because I've lived in Los Angeles, so. Or Los Angeles County.
I would not do that.
I would never move back to California or even. Only place I'd move back to California is maybe like Northern California, but I just don't want to be in that state anymore. I'm glad I moved to the Pacific Northwest. My husband and I are probably going to move into Idaho in the next like 5-10 years, I think. We have friends there. I love it.
Even less people.
Yeah, exactly. I don't have any other questions. I don't know if anybody else has any other questions. I feel like I'm the only person that's been asking questions. So.
Yeah, nobody else talking today. The talkers didn't log on. All right, I guess I'll call it a night. And if you guys have any questions, then message me.
All right.
Have a
Thanks,
good,
Rob.
yeah, have a good night. Bye.